Yeah, hi. Uh, Welcome to the week 5 practice discussion session. Okay, so we will discuss the practice assignment questions of the week 5. Okay, so before starting the session, anyone have any query, any doubt?
Sir,
Yes, Srinivas.
sir, do we do any revision for tomorrow's test?
Yesterday, I think one session we have conducted, no,
Yeah, yeah,
where the mock
yeah, yeah.
questions are
I
discussed
saw this.
actually.
Okay, sir,
Yes.
but today we will not do such things, no, sir. Only week 5 we will be discussing, right?
Yeah, so if you have any doubt in the previous contents for the first 4 weeks, then you can also ask. Okay. So
Yeah,
because
okay, sir.
tomorrow is the quiz, so if you have any doubt, you can ask.
Yeah, okay, sir.
Yeah,
Yeah,
but
no doubts. No, yet, sir. If something, I will ask.
okay, okay, okay.
Thank you, sir.
Actually,
Sir,
this session is scheduled for the week 5 because week 5 content is also released. So because of that, we are conducting this session for week 5.
Yeah,
Otherwise,
okay, okay.
if you have any doubt in first 4 week, then you can also ask.
sir, I'm having a doubt in the mock test, sir. Question number 13.
In the mock, okay. So have you joined the yesterday session?
Yes, sir, but I didn't understand once. Can you please explain
Okay,
it
okay.
again?
Let me open one second. Okay, so you are talking about the mock. Question number 13.
Yes, sir, 13.
11, 12, 13. This one. Okay. Okay. So here one code is given. Okay, and where x is an integer, and we are asking that what will be the value of which option is the correct option. Okay. So just look the code. Okay, and so what is given in the code actually, we are checking if x is greater than 2. Okay, this is the first statement. Then we are multiplying by 2 into the x and updating the value of x. And the second if statement is checking if x is greater than 4, then we are setting x equal to 0. So just tell me here, this first if is separate to the second if or not?
Yes, sir.
It is totally separate now. That means if first condition is true, then the internal part will be execute. If the, and we will also check the second if, because this second if statement is totally separate of the previous if statement. So both will be checked. Okay, so according to the code, so we will check this question from the option, because code is given, we have to check the which statement is correct. So x will always be 0. So the first statement is saying that x will always be 0 after the execution of this code for any value of x. So is this true? Because
No,
suppose if we pass x equal to 1, then what will be the value of x finally?
2.
No, if x equal to 1, then first statement is true or not?
Yes.
No. So 1 is
No,
greater
sir, no,
than,
it's not. It's not true.
yeah. If we are passing x equal to 1, so 1 is greater than 2, no. Okay. So that means that first statement will not be executed. And if we check x is greater than 4, so 1 is greater than 4, no. Okay. So that means both condition are false. Then we will directly return the print statement x value. So that means output will be 1. So you can see the first statement is saying that x will always be 0 after the execution of this code for any value of x. So we have just taken one sample value of 1, and we are getting the different output, not 0. So this statement is not correct. Okay. Now, second statement, if x is greater than 2, the value in x will always be doubled after execution of this code. So if we are passing x is greater than 2, so that means we can pass 3, 4, 5 like this. So it is saying that x will always be doubled after this execution of the code. So is this true? Because if we are passing 3, suppose, okay, so 3, so first condition is now true, and then our x will become x into 2, so 3 into 2 6. Now x value is updated. Now we will check the second condition. So x is greater than 4 now, yes, so 6 is greater than 4, correct. At this time we are changing this value x equal to 0, x equal to 0, and finally we are printing this, so our output will be 0 in this case. Okay, but it is saying that x will always be doubled after execution of this code. So after execution of this code, x will be doubled, but this is not true. We are giving 3, but we are getting 0 in the output. So this statement is also not true. Then if we check, if x is greater than 2, x will always be 0. Is this correct? Because if x is greater than 2, so you can see in the code, if x is greater than 2, so our value will always be doubled. So if we are passing 3, so 3 will become 6 in the first statement, then second will also be true. So for any value of greater than 2, the both condition will be satisfied. Both if statement will be satisfied, and second if statement are actually setting x equal to 0. So that means if our x is always greater than 2, you will always get 0 by the second statement. So if you are passing 4, so first statement, first condition is true, then 4 will, this it will become 8. Then 8 is greater than 4, yes, second statement is also true. Then we are setting x equal to 0. So if any value of greater than 2, your x will become 0 after this execution of this code. Okay, so in this case, yeah, you can see we are getting 0 always. And last statement is x will always be doubled after the execution of this code for any value of x. So you can, we have already seen for 1 we are getting 0, and for remaining value we are also getting different, okay, greater than 2. But only 2 value, so for, yeah, for 2 value also we are getting x equal to 2, but more than 2 then we are getting 0. So this is also not correct. So only one statement is actually satisfying always. So option third.
Sir, and also question number 17.
Okay. This one?
Yes, sir.
Okay. Okay. How many times will the following code, following C code print hello C? Okay, the answer should be integer. Okay. So here we are asking that how many times this hello C will be printed by the code. So if you see the loop, here loop is running. So first loop, can you see, you can see I is starting from 0, and condition is given I is less than 5. That means it, this I value will be increased like this: 0, 1, then 2, then 3, then 4 only. Okay, so 0 to 4. For 5 value, this condition will become false. I is less than 5, it will become false. So we will run this code for I equal to 0, then 1, then 2, then 3, then 4. For each value of I, this inner, this is the second loop. Okay, and this second loop is running inside the first loop. So that means for each value of I, our j loop will run. So our j loop is running from 5. Okay, so here we are starting from 5, and we are decrementing this time, and we are decrementing until our j value is greater than I. Okay, so condition is given like, so j is greater than I, we will decrement this one by one. So for, we will check this. So whenever I equal to 0, okay, so whenever I equal to 0, so j loop will start from 5, and it will run till greater than 0. Okay, so here we are setting j loop will run till j is greater than 0. So I value is now 0. So this decrement will happen like this. So 5, then 4, then 3, then 2, then 1. Okay, then it will become 0. So this will, condition will become false. So that means for I value, when I equal to 0, so this internal loop will run from 5 to 1. So that means 5 times. You can see it will run 5 times. So it will print 5 times this hello C. Okay. And same, now we will increment our I equal to 1. So J loop will run. So here condition will become J is greater than 1 now. So J will start from 5, then 4, then 3, then 2. Okay. Then after that it will become equal. So condition will become false. So in this case, our loop is that print statement will perform 4 times. Okay. Now I equal to 2. So J loop will run 5, comma 4, comma 3. Okay, greater than to the I value. So here I value is 2. So J should be greater than 2. So only 3 times. Now when I equal to 3, so J will run 5, comma 4. Okay, so J is greater than 3. So these two value are satisfying this. So this is 2 times. And when our I equal to 4, this is the last value. So J loop will run only 5. So that means J should be greater than 4. So only 5, 1 times. Okay. So this is the condition when our print statement will perform. So okay, for each value of I, first for the I, when I equal to 0, 5 times print statement will perform hello C. And when J I will become 1, so our J loop will run only 4 times, then 3 times, then 2 times, then 1 times. Okay. So now add all these numbers. So 5 plus 4, 9, plus 3, 12, and 14 and 15. So total 15 times this print hello statement will be performed. Okay. Is it clear?
Yes, sir, got it.
Okay. Any other question?
No, sir.
Okay. Any other? From mock or any previous 4 weeks? Okay. So if there is no query, then we will move to the week 5 and we will discuss the programming questions from week 5 practice assignment question. Okay. So in week 5, actually, we are looking the function topic. Week 5, we have the topic function, and we will write the code through the function. Okay, so we will create the function for solution here, and we have discussed all the basic things regarding the function in Tuesday session. If you have not joined, then you can watch the video, and you can also watch the lecture of the week 5, so you will know what is the function and how we can write the function. So based on that concept, we will solve the problems which are depends on this function and recursion concepts. Okay. So now first, this is the first PPA, practice programming. So now from week 5 onwards, we have only 5 PPAs and 5 GRPAs. And if you know that from today onwards, from today actually we are also releasing this timed mock. So today is the first day we will release, and for the first timed assignment we will release this 4 days. Okay, so that today, then Sunday, then Monday, then Tuesday. Okay, so you can attend this timed mock in any one day, or maybe in the combination. So you can solve 2 problems in one day and 2 problems in the second day, like this. Okay. So now the first problem, just look this. You have, I think you have already solved this problem using simple method. So to complete the given C program, write a recursive function named fact that takes a positive integer as input and return the factorial of the input integer number. Okay. So here some part of the code is also already given. You can see. Okay, so you can see this code here. One header file is given, main function is also given. In main function we have declared one variable a. Okay, and because we are calculating factorial, so we will store the result in long variable. Okay, so because our result may become very large, so because of that long variable is we are taking here. So this is given in the problem code. Okay, so long int, so that means we have declared one variable result. Okay, the type of that variable is long int. Now we are reading one input a value, and we are calling this function. Okay, so here we are calling this function fact a, and we are passing a as a input in this fact function, and finally we are printing result. Okay, so what value this function will return, that will store into the result variable, and that value we will print as a output from this code. Okay, so the question statement is very simple. Fact variable, that means we are calculating the factorial of given input. Okay, so but here the things is different. This problem is very easy if you are writing the code normally using the for loop, but here it is asking that write a recursive function. Okay, so we will try to write a recursive function for this. So you know factorial means, so if we are asking that fact of 4, so this means this operation should be performed. So like 4 into 3 into 2 into 1. Okay, this is the value of factorial 4. Similarly, factorial 5 we will add, so fact 5 we will write like this. So 5 into 4 into 3 into 2 into 1. So in this way we can calculate the factorial value. So if any value is given, like a value is given 10, so that means our output should be 10 into 9 into till 1. We will multiply all the number from 10 to 1. So this value will be represent as a factorial of the given number. So how we can solve using this as a recursive function? So if you know the recursive function definition, so recursive function means if our function call itself, okay, if our function call itself from the body of the function. So suppose if you are writing any function uh, and it is taking some input, and inside this body of this function, after some statement, so we are calling the same function from inside the body of this function. So like fun, and we are changing some variable like a minus 1 like this. Okay, so that means the function, this is the function, main function, and from inside this function what statements are written inside the body of this function, at one statement is a calling the same function. Okay, same function fun we are calling from inside the body of the same function. So this concept is actually called as a recursive function. So how we can use this concept to solve this factorial problem? So can we write, suppose if we are asking like this factorial value equal to 5. Okay, so can we write like this 5 into and fact 4. Okay, so here this is the main problem we have given, fact 5. That means we want to find out the factorial of 5. And if you know that, what is the factorial value of 4? So factorial value of 4 is 4 into 3 into 2 into 1. Okay, so that means this factorial value will return this the value of this multiplication 4 to 1, and we are multiplying this in this value by the 5. So then that means we will get the result of overall factorial 5. So that means we can write this function like this. So fact 5 equal to 5 into fact 4. Okay, similarly, can we replace this fact 4 like this? So 4 into fact 3. Okay, so you can see if we replace this, so like this 5 into 4 into fact 3, still we will get the same answer, because this function will return the answer of factorial 3, and we will multiply by 4 and then 5. Okay, then we will get the final answer fact 5. Similarly, we can replace this fact 3 part as a fact 2, and before this multiply 3 into 4 into 5 like this. Okay, so similar, we can also replace this like a fact 1. Okay, and before this 2 into 3 into 4 into 5 in this manner. Okay, so and for fact 1, because you know that for fact 1 you can directly return the answer like 1. There is no need to calculate again. So if we are passing a equal to 1 to the function, so factorial of 1, you know that the value is 1. So at this place you can directly return the answer 1. So you can replace this by a 1. So in that manner, you can design your code also. Okay, so we can design a function, and inside the function we can call the function recursively. So when the function will call, so it will repeat the same process again. So when we are calling function 5, so it is satisfying, it is taking this input as a number here for multiplication, and multiply fact 4. Okay, we are reducing the one input value 5 to 4. And when this function will be called, so we will replace this by a 4 into fact 3. So in this manner we will reduce the value of the input in the each call, and we will multiply by the same number. So if you can design your code in this manner, then that function will be called as a recursive function. So in recursive function, basically there are two properties are important to for the design. First is base case, and second is recursive case. So every recursive function contains these two types of situation. So the both type of situations should be there in the recursive function. So first is base case. Base case means one condition should be given inside this recursive function, so where your code will terminate actually without calling recursive again. So one condition we mention where our code will terminate without calling the recursive call again. That part is actually called as a base case of the recursive function. And remaining part where we are calling the same function again, that is called as a recursive part. Okay, so base part and recursive part, both parts should be required for the recursive function. So that means after some recursive call, repeatedly call, our function should be terminate. Okay, so that then we can end our final code. And otherwise, if in your code base case is not given, then your code will not terminate. So here same things what we will do, we will design this factorial function like this. So fact, okay, and we are taking a input as a input number where we want to calculate the factorial number of this a value. And inside this base case, inside this function, we will write first base case. So base case we can create like this. So if our input is 1, so suppose if we are passing a equal to 1, that means we can directly return the answer 1. Okay, there is no need to repeat again. So what we can do, we can write if condition, if a equal to 1. So if this condition is true, then return 1. Okay, so this is now base case. If any time this condition is true, so your function will return 1 only without calling recursive again. Else part, if your a is not equal to 1, in that case you will call recursively. Okay, so recursively means you will call the same function, so return. And here what value you are taking in as input here, so a into, okay, and we will call this function recursively, but we will reduce the input by 1. So we can write like this, so fact and a minus 1. Okay, and this is the statement. So now you can see here we are if we are passing a equal to 3 in the initial, so that means a equal to 3, so first condition is not true, then else part will be run. And else part is actually a, so what is the a value current now is 3. Okay, then multiply, and we are calling fact function, same function again, so fact a minus 1, that means 2. Okay, now this is the new call, that means the same code will run again from this position. And now this time we are passing a equal to 2. Okay, in the new function this a will become 2, and pass so here in the new call just pass a equal to 2, then first if a statement is not true, and then second else statement will run. So that means when we are calling this function, so this function will execute again this return statement. Okay, so return statement means, so return, and here again, so return a. So at this time a value is now 2. Okay, so 2 into, and we will call fact a minus 1, so fact 1. Okay, so once again when we reached as this statement, so this is again a recursive call to the same function. Okay, so fact and once again, now this time we are passing a equal to 1. So when we are passing a equal to 1, you can see first statement is correct. If a equal to 1, this statement is true. At this time, this function will return directly 1. So here return 1 directly, okay, and else part will not execute. So now this recursive call complete, and you can see we are returning 1 here. So that means this 1 value will replace this part as a 1. So now operation will be performed. So 2 into 1. So this will become return 2, and 2 will replace this complete part like this. Okay, 2. And 3 into 2, it will become 6. And this 6 will return as a answer to the main call where we have started this call. So 6 will be returned to the main call, and that this is the answer for the main call where we have started when we pass equal to 3. So we can write this function as a solution in this code. So here we need to write a function fact, okay, and this is returning a integer number. So we can write like this. So int fact, okay, and we can just write any variable name. Okay, so no need to write a over here. So you can write any variable names like int n. Okay, you can write any in the designing of the sorry. So this is the function structure. Now we will write the code. First base case. Okay, so first if our n equal to 1, so in that case our function should return 1. Okay, this is the if part, and the else part we will write the return statement with recursive call. So return and n value, so we will multiply by n, okay, n into, and the same function call. Okay, so fact, and we will pass, we will reduce the input. Okay, so why we are reducing? Because our base case is equal to n is equal to 1, and we are starting some value from which is greater than 1. So that means in every recursive call our input should be reached to the base case. Okay, it should be reached closer to the base case. So if we are decrementing that, then you can reach to the base case. Otherwise, if you are incrementing on like this, so you will never reach to the base case. So here we are writing n minus 1. Okay, so now this will execute in the similar way which I have explained. Okay, and when we run this code, so you will get the answer. Let me check. Okay, now you're getting the correct answer. So if for input 3, answer is 6, so expected output, and both are matched. For 4, 24, and if you run this code, you will get the all test case correct. Okay, 5 out of 5 test case pass. So in this manner you can write the recursive function, or you can also write the non-recursive function here. So we are not restricting to anyone here to write the recursive function only. Okay, so if you know the factorial simple way, so you can write that simple way also. That is simply by the for loop, run the loop from n to 1 and multiply the all value. Then you will get the answer. Okay, so this is the solution for the PPA1 first problem practice. Any doubt in this? Anyone? Okay. Now second problem. Second problem is also very similar to this.
Sir, may I ask you one question
Yes.
from week 4
Yes,
graded
yes.
week 4 graded last assignment PPA 8.
Okay, 1 second.
Week 4
Week 4 I have opened. Which question?
last graded last 8.
Yes.
Sir,
Yeah.
I can't do this, please.
Okay, so I think solution code is available.
No.
No, it is available. When you select the language, you can see the solution code. Okay, and okay, let me just explain this solution. So here, what is asking that you are developing a program for a grocery store that keeps track of the total cost of the item in a shopping cart. Write a C program that allow the user to input the price of item as float one by one until they decide to stop. Okay, use a loop to continuously prompt the user for item price and calculate the total cost. Once the user decide to stop, print the total cost as float up to 2 decimal point. Okay, and what is the input format? You can see we are giving input format like this, so the price of item is double. Okay, double is also a uh, different types of float value. Okay, and the user choice as a single character if y. Okay, so if user are pressing y character, then go to step 1 again. Okay, step 1 means this it will read the value again for the new item price. At any time if user is pressing n, okay, then print the output. Print the output means the total cost. So how this actually behavior is, so that means our program is running and we are asking what is the price of the item first. Okay, so item first price is like 50. Okay, we are giving this value as an input to the user like 50. Okay, and we are also maintaining one variable like total, and we will add all the input value in this total variable. We can start with this 0, and when our user is giving input 50, so this 50 value will be added into this total value. But after giving this input, we will ask user to input y or n. Okay, so that means second line input is a single character. So if user are pressing y, okay, y character, that means user want to give more in item cost. So that means our that means our input statement should be performed again, and then user will input some value again like 100. Okay, and once again we will ask to the user that he or she want to input more elements or not. So suppose once again y. Okay, that means once again we will ask to the input by the input statement, suppose like 150. Okay, and at this time, at any time if user press n, okay, so at this time our process should stop and this total value should be print. So at each step we have to maintain this total also, so total equal to 0 plus 50. Okay, and when it is we are getting second input, so total is now 50, so total equal to 50 plus 100. Okay, so like 150, and at this step total equal to 150 plus 150. Okay, now 300, and now n, so this total value should be print, so on output should be 300 like this. Okay, so how you can run this type of code, so where for each input press, okay, so y and n, you have to execute the same scanf statement again. So you can do this using the while loop. Okay, so you have already learned one statement do while in the Week-4 do while loop. So what we can do, we can write do statement, okay, and then while. So while is the condition. If this condition is true, in this while condition is true, then we will repeat this do statement again. And what we will do, what we will do inside the do statements, we will just read the first value item value. Okay, so that means first item value means like we will write the scanf characters. Okay, so scanf, and that is the item price, so we can write simply percentile d and item price. Okay, so like price, or if you are reading as a float value, you can write this here f float value. Okay, if you are writing a long value, so lf, like. So you have written this scanf one time. Okay, and now you can just maintain this total equal to what, so what value you are getting, total equal to total plus price. Okay, Now this is the next statement, and third statement just read the choice. So what choice actually user want to press, if he want to press one more value or not. So again you can use the scanf character like this. So percentile C, because we are reading the as a character. Okay, and we can write choice, and we can make this condition. So what character we are reading inside the choice variable, we can write the condition inside the while. If choice, or no, if choice equal to character y. Okay, so that means we are what we are doing, we are reading a input price, then we are adding that price into the total, then we are reading the second input as a yes, y or no, n as a character. Okay, y or n. So if user is inputting this y value, so this condition will become satisfied as a true. That means this do loop will run again. Okay, this loop will run again it will ask for the next price. Okay, then we will perform the total again, and then we will ask again choice. Okay, so we will repeat this process if we are getting the same input character y inside the choice. At any time if we are getting the different character like n, so this condition will become false, and we will execute the next statement. What statements are written after this? So we can like simply print and value of total. Okay, so like percentile lf, or like this f, and total like this. Okay, so once the while condition will become false, this print statement will run, and our total output will be printed. So in this manner you can design this code when you are reading the input continuously based on the choice value y or n. So the code, you can see the solution for this. So what we are doing, we are maintaining two variable, item price and total cost. Okay, so both are actually double the float value. Okay, and total cost is just assigned as a 0.0, and we are also maintaining continue shopping. This is the second variable. Okay, so, and this is similar to the choice. So what user actually giving the choice, and we are performing do loop first. Okay, till here we are reading the item price first, and we are adding into the total, then we are reading the choice. Okay, continue shopping. So what value we are getting inside this second variable? Okay, continue shopping. So if suppose if we are getting y, so this while condition will become true, and this do loop will run again. See, okay, so based on our input value y or n, this loop do loop will repeat, and when we are getting y, this continuous shopping as a n, so this loop will terminate, and our final statement will perform total cost. Okay, so
Okay, sir.
yeah, you can design in this way.
Okay, sir.
Okay, next. Okay. So yeah, next PPA of the week 5 is this: to complete the given C program, write a recursive function. Oh, this is written 2 times. Okay, write a recursive function some natural numbers that accept a positive integer n as input and return the sum of all natural number from 1 to n. So this is very similar to the factorial, because in factorial what we are doing, we are multiplying from n to 1. Here we are adding from n to 1. Okay, only the sign difference is there. So sum of n natural number means if we are passing 5, so our answer should be 5 plus 4 plus 3 plus 2 plus 1. Okay, so in the previous was, in the factorial was 5 into 4 into 3 into 2 into 1. So same way you can design the function for this. So if you are writing the sum, so sum, if you are passing 5, you can also write 5 plus sum 4. Okay, and this sum 4 you can also write 4 plus sum 3. Okay, and this you can write like 3 plus sum and 2. So in this manner, you can repeat the process, and at any time, if you are getting 1, you can directly return 1. Okay. So you can write this code in the similar way for this also. So here some code is given. So the function name is required some natural number. Okay, so this is the required function, and we will write this function. So return type is integer. Okay, and we can take we are reading integer variable, so we can write like int n, and inside this function first base case. So if input value n is equal to 1, okay, so we will return the 1 directly, return 1. Else part, we will return, so n plus, this time plus, okay, because we are adding all the numbers. So n plus the same function name, so we will call this function recursively. So the same function name we will write here, and we will pass the value 1 less. Okay, so n minus 1. Okay, now this will run in the same way, and you will get the sum of the all n to 1 number by this code. So when you run this, you are getting the correct answer for first. What is the sum of 10? So 1 to 10 is 55. Okay, so 1 is 1, it is 36, like this. So this is very similar recursive code, and you can submit the code. Okay, next PPA 3. Okay, this is different problem. So here a positive integer m is a prime product if it can be written as p into q, where p and q both are primes. Okay, so you know that what is the definition of prime. So what is the prime number actually? The number which is greater than 1. Okay, if number is only divisible by the number itself or 1, so that number is called as a prime number. So here what we are asking that, let me take the copy. So first we will understand the problem statement, and then we will try to find out the logic for this. So any number input is given, like, so one sample input is given 10. So we have to figure out the factor of this 10. So some other factor value p and q. Okay, so if we multiply this p and q, our output should be equal to 10. Okay, so that means p and q should be our input 10, like this. And if our p and q both are prime number, if our p and q both are prime number, then we can say that this 10 is a prime product. Okay, so how you can figure out this? 10 is a prime product, so input number is a prime product or not. So what you can do, first thing is requirement is you have to check after finding out the product. Okay, so suppose if you are checking the product and you find it out, this p is the product of p and q both are the product of this 10. Okay, so if you are getting p into q equal to 10, but still you have to check that this p and q both are prime or not. So you have to write a function to check the number is a prime or not. So I think in the input code, let me check if this is given or not. Okay, so prime function definition is not given. So here you have to write the separate function for that. That means you have to write two function here. So, or you can do in the different way also, but for the code, you can, what you can do, you can write a separate function to check prime number. Okay, so you already have written this code in the previous weeks, a number is a prime or not. So suppose if you are writing a prime function, and that is taking some n input. Okay, and this function is returning like 1 or 0. 0 means false and 1 means true. So if number is a prime, then return 1. If number is not prime, then return 0. So that means that we will write separate function to check number is a prime or not, and we will also write this function prime underscore product, and we will figure out the this p and q, what p and q possible for the input number, and after finding out this p and q, we will just check this p and q both are prime or not. Okay, so how we can start this? So we can write the function for prime checking first. Okay, so prime checking means just write the function like int okay. So like int, and we are like checking as a prime. Okay, and we are passing int n here, and inside this function we will just check n is a prime or not. Okay, based on that we will return the answer. So to check the number is a prime or not, if our number is divisible by from 2 to that number, okay, so not that included, if our number is divisible by any number of between this 2 and 1 less to the n, so that means we can say that our number is a not prime. Otherwise our number is a prime. So we can take some variable like int result, okay, and we are setting this as a 1 true, okay, true initially, and after that we will run a loop. So for okay, so here int I, okay, so I have declared one variable I. I'll start with this I value from 2, okay, and I will so I'll take this condition, our I is less than equal to n. Okay, we will not include n because every number is divisible by the itself. Okay, so that should not be happen, and we will increment this I by 1 in the each time, so I plus plus, and inside this loop we will check the division process. Okay, so if our n is divisible by this I, okay, so then divisible means, so we can write the percentile operator here, and divisible by I equal to 0. Okay, so what we are doing, we are dividing this n by I. Okay, this loop is a this is a loop, so we will get I equal to 2. First we will check by the 2, then we will check by the 3, then 4, in that way. Okay, if this n is divisible by any number from this range 2 to n minus 1, okay, then we can say that our number is a not prime. So what we can do, if this condition is true, then we can break the loop, and we can return the answer also. So we will write like this. So or we can set our result. So res equal to 0. Okay, res equal to 0. 0 means false, and we will break this statement. Okay, break means no need to check the remaining process because we have found the product. So break, now our loop will break. So this loop will run, and we will get the final value of res. If our number is divisible by any given range number, so that means our number is not prime. Otherwise our res value will remain same, 1, if our number is not divisible by any number. And finally we will return the result value. So return this res. Okay, so now this is the function to check number is a prime or not. Okay, so suppose if we are passing n equal to 3, so we will set this res equal to 1, and our range will start from 2, only 2. Okay, so next value is n equal to 3, so that means only 2. Now we will check this condition, 3 is divisible by 2, so you will get the remainder 1. No, okay, so this condition is not true. So and your loop will terminate. So loop will terminate, then that means your res value will remain 1. 1 means your input is prime number. Okay, 1 means true. Okay, and 0 means false. So this function we have written to check the prime number. Now the main function. Okay, so the function which we need to write, that is actually prime product. So we will write the second function now, int prime product this. So prime product, this is the main function which we need to write. If our number is prime product, so we will return 1. Okay, so based on our output return value of the function, this prime product, if this is a 1, so you can see in the main function we are printing that m is a prime product. Okay, if our return value is 1 equal to 1, then output is a prime product. Otherwise, uh, our input value is not prime product. So that means we have to return this 1 and 0 by this prime product function. So how we can check number is a, how we can find out this p and q now. Okay, so that let's discuss this. So here input is given 10. Okay, so what we can do, we can run a loop. So we can run a loop from like this. You can start from 1. Okay, so you can start from 1 to 10. Okay, and you can check if this 10 is divisible by this input number or not. So we are starting from I equal to like 1, then 2, then 3, then 4, like this, and till 10. Okay, so this is the basic approach. So suppose if we are dividing by 1, so you will get the remainder 0. That means this 10 is divisible by I 1. So 1 is the product. Okay, and so this is the reminder. That means this 10 is completely divisible by I value. Okay, so initially we are checking with this 1. So what are the, so this we can consider this as a p. Okay, and how we can find out the that q value? So you can simply, this is the percentile operator, and for q value you can simply write like this. So 10 division I. Okay, if this condition is true, if remainder is 0, then you can simply write 10 division I. Okay, so both are integer value, so it will return a integer value as the answer. So you will get the q value here. So 10 value you will get as a q equal to 10. Okay, so 1 into 10 you are getting 10. Now you can check 1 and 10 both are prime or not. So here 1 is also not prime, 10 is also not prime. So 1 is also always not prime number. So what we can do, we can remove this 1 from our checking range, because this 1 will always a not prime number. So no need to check this. You can start from 2 to 10 like this. So we are not getting this solution. Okay, second we will check from 2. So 10 remainder 2. So yes, we are getting remainder 0 here. So that means this 2 is a product of this 10. Okay, and we are getting the 0 remainder by this. Okay, so we can write like p equal to 2. And what are the q value? So q value you can find out 10 division by 2. So 5. So that means q equal to 5. Now 2 and 5 you are getting. 2 into 5 equal to 10. Now you check that 2 is a prime or 5 is a prime. Both are prime or not. So yes, 2 is a prime and 5 is also prime. So if both are prime, then you can return the answer as a true. Yeah, this 10 is a prime product. Okay, so this you can repeat this process at any time. If you are getting both number as a prime, you can stop the process and you can return answer. So these things we have to write in the code. Okay, so what we will do, so we have m value here. So we will declare this two variable int p and q. Okay, after this we will run the loop for int I in range. Sorry, I'm writing the Python statement. Sorry, for int I equal to 2 and I is less than 2. Also no need to include this m number. Okay, so less than m and I plus plus. And inside this function we will check this condition. So if our this m is divisible by 2. Okay, so divisible by I equal to 0. If this condition is true, so inside this what we can do, we can decide the p value here. So p equal to m percentile I. Okay, so one value we have received from here. So if remainder is 0, so that means our p value will become, or not, this. Okay, p equal to I. Now for q value, so you can write like this. So q equal to m divide I. Now check if both are prime. Okay, so prime means we have already written the function this prime, so just pass this value p and q. So if prime p and take the condition and, so and condition and prime q. Okay, if both are true, okay, so prime p and prime q, so if both are 1, then overall condition will become true. So in this case we can return the answer directly. So return 1. Otherwise, if we are not returning this statement, then we can directly return 0 from last. Okay, so if this condition is satisfied, our output will be returned from this position, and our loop and all the things will terminate at this position. Otherwise, return 0. So in this manner, we can write the solution for this. Let me check the code. So we are getting some error. Okay, wrong type of M default and prime product M. What is okay? M prime product M. Oh, okay, the error is here. So this is I plus plus. Okay, still warning. In prime product. Okay, this is also. So you can see this is the solution for this. So first statement, this first function is actually checking only the number is a prime or not. Based on that, it is returning the answer. And this is the main function. Here we are just checking, finding out the p and q first, and then checking if our p and q both are prime, then we are returning 1. Otherwise, if this loop is terminated without this return statement, then we will return 0. Okay, so then this is the answer. Any where in this? Is it clear?
Sir, is this only process to do this?
So if you find any other logic, you can also try. So right now, this is the logic which comes in my mind. And if you are finding any other logic, you can also try. But still, you have to do the same things in the process. No, so first things you have to figure out the p and q both. Then you have to check the p and q both are prime or not. Then this things is the required things. But you can simply change the loop structure or the condition structure like this. Otherwise, these are the required things which you have to check.
Okay, sir.
Okay. Code structure you can change. So I have written this code statement like using the 2 functions. So you can use the only 1 function and you can check the prime number in the same statements. Okay, you can write the same prime checking code into the same prime product statement also by writing the repeatedly code. So that will increase the code length of the prime product. So because of that, I have separated that, because you have already written this prime checking code in the previous assignments. So you can use that. Okay, so this is the solution for PPA 3. The next, okay, PPA 4. So here the same things, Fibonacci series is given in is an infinite series starting from 0 and 1, in which every number is in the series is the sum of the two numbers preceding it in the series. For example, this is the series given where the 0th Fibonacci number is 0 and first Fibonacci number is defined as 1 and so on. So to complete the given C program, write a recursive function. So recursive function is asked here. So write a recursive function nth Fibonacci that accept a non-negative integer input n and return the nth Fibonacci number. So suppose if you are asking the fourth Fibonacci number, so fourth Fibonacci means, so this is 0, this is 1, this is 2, and this is 3, and this is 4. So fourth Fibonacci means this 3 should be the output. Okay, and the sixth Fibonacci number is this 8. So this is coming as the output. So we have to write the code using the recursive function. Okay, so recursive function means, and you know that this every value is calculating by the sum of previous two value. Okay, in this terms, this Fibonacci series terms, we are getting the new value by adding the previous two value. Okay, so this 5 value is coming from 2 plus 3. Okay, this 8 is coming from 3 plus 5, like this. Okay, so we can use the same logic in the recursive manner. So suppose if we want to find out the nth term, so as a base case, so what base case we can make? So like uh, if our input n, if our input we are giving n, that means this is representing the nth term. Okay, so if n is equal to 0, okay, so n is equal to 0, you can directly return 0, because you know the 0th term is always 0 and first term is always a 1. So this is the two first term, so return 0. And second condition, if n equal to 1, then you can also write return 1, return 1 directly. Okay, so now you have these two base case, 0 and 1. Now after that, if n value is greater than this one value, okay, suppose n equal to 2, then 3, so you can use the same formula. You can add previous two value by the recursive manner. So recursive manner means, so else part, if these two conditions are not satisfied, okay, so we can write these two condition in one case, and other part what we can write, return. So suppose if we are passing n, okay, so what we can write, if our function name is like rec, okay, not fib, if you want key, okay, so what we can write, fib to n minus 1, okay, plus fib n minus 2. Okay, so if our n equal to 0, we will directly return 0. If n equal to 1, we will directly return 1. If n equal to 2, so suppose n equal to 2, so what we can write this statement like if f fib, so that means to getting the second term, we have to add 0th term and first term. Okay, so we are doing the same thing. So we are getting the one less. Okay, so one less means if we are getting 2, so that means fib 1. Okay, what is the value of fib 1, and plus what is the value of fib n minus 2? So this is 2 minus 2 will become 0. So previous two terms actually we are finding out, so n minus 1 and n minus 2. So if you will add this function as a recursively, so this is a new call now, okay, with the input 1 and this is input 0. So when you are passing input 1, so this first base case will be run, sorry, the second case will be run. So here you will get 1 directly, okay, return 1. And in the second call, fib 0, so you are passing the n value equal to 0, so this first condition will be true, n equal to 0, and return 0. And you will get 1 plus 0. So for n equal to 2, you will get answer 1 again. So this is the second term. Okay, same way, if you are finding out the n equal to 3, so you can write like this. So fib return statement, return Fib for 3, this is the 2 plus fib 1. Okay. Now this is the recursive call. Okay. So here we are passing the n equal to 2. So this n equal to 2 will again divide into two statements. So this statement will again return fib 1 plus fib 0. Okay. This first statement, this will be replaced by this. Now this fib 1 will directly return 1 and this fib 0 will directly return 0. Okay. And this above 1 also return directly 1. So here you are getting 1, 1 plus 0, 1. Okay. And here you have 1 plus 1, 2. So overall will be replaced by 2, return 2. So that means next statement, third term is 2. So in this manner, we can design the recursive code for this. So we can write the statement. Okay. So function name is nth Fibonacci. So int okay, and this n should also be defined as a int. And here base case. So base case we can write if our n equal to 1, 0, we can write n equal to 0, then we can directly return as the answer 0. Okay, this is the first statement. Second statement, if n equal to 1, then we can directly return 1. Okay, and third condition, if our n is greater than 1. Okay, so n is greater than 1. So in this case we will call recursively. So recursive means we will return answer same statement. So nth Fibonacci. So we will pass n minus 1 and plus n minus 2. So this is n minus 1 and plus n minus 2. N minus 2. So now this is the complete part. Okay. So here this is the base case. First two conditions are base case and this is the recursive case. So if n is greater than 1, so we are calling the recursive function. We are finding out the last term and second last term. Okay. And we are in this manner, so this will reach to the base case at any point and it will return the answer repeatedly. So we run this code. Yeah, so all output is correct. 0 term is 0, 1 term is 1, 6 term is 8, 10 term is 55. So in this manner, you can get the all Fibonacci nth term. Okay. Any query in this? So recursive function is actually just you have to imagination how the recursive call is actually executing. So it will create some time to get this logic. So just try to solve some basic problems, some very basic problems using the recursion, and then after that you will get the how the actually execution happening, how the what is the flow of execution actually. Okay, so then you will understand this recursive things. Okay, now next is PPA5. Okay, so here in this problem statement, to complete the given C program, write a function nth digit that accepts two integer num and n, and return the nth digit of the number num from right to left. Okay, if n is greater than the number of digit or less than or equal to 0, so return -1. Okay. So what is asking that here number is given. So this first value is also a number. Okay, and this is another value. So this is num num and this is n. So this is representing nth digit. Okay, so if our digit n value is equal to 0, so zeroth digit is no meaning here. So 0 or any negative value. Okay, so any negative value or greater than the length of the digit, then our output should be -1. Suppose in this 1 2 3 4 5, we are asking that what is the sixth digit in this from right to left. Okay, so we know that first digit is 5, second is 4, third is 3, fourth is 2, fifth digit is 1. Okay, from right to left. But after that there is no sixth digit in this. So suppose if our n value is given 6 for this input, so our output should be -1 in this case. So this is actually invalid input, so we can return -1. And same things, our n equal to 0, then our output should be -1. If n value is equal to -1, -2, any in this way, so output should be -1. If our n value is valid value, okay, so like in this case second 2. Okay, so 2 means from the right position, so this is the first and this is the second, so this 4 should be printed as a output. So in integer value, how we can find out the any particular digit from the right to left? So what logic you can apply here? You can apply the division process. So here 1 2 3 4 5, this is given. Okay, so you can run a while loop here based on this input digit value 2. Okay, so you can run this loop 2 times, and every times what you can do, you can divide this value by a 10. Okay, and also you can also take the remainder. So what first remind this value, take the remainder value by the 10. So if you are taking as a reminder by 10, so you will get 5 from here. Okay, so 5. So because it will be completely divisible by 1 2 3 4, and 5 will remain remainder. So this will be considered as a last digit. Now after that, change this value. So how you can change this value? So just divide by value. Okay, so you can set as a num equal to num divide by 10. So when you are dividing by this, so this decimal part will be removed and you will get only 1 2 3 4. So that means one digit is now removed. Okay, now the repeat this process one more time because our n value equal to 2. So we have repeat one time this process. Now we will repeat the second time this process. Okay, so once again we will get the reminder for the new value. So 1 2 3 4, what is the reminder value by 10 is now 4. Okay, and this is the second iteration, so that means we have completed 2 iterations, so we can return this as the answer. So if our iteration number is equal to n, then we can return this as the answer directly. So in this manner you can find out the digit. So I repeat this process, what n value is given. Okay, and every time update this num as a new value, so we can figure out the digit from the right to left. So what digit we actually finding out? So you can write the code using the same logic, or first what we can do, okay, so this is the main function given here. So integer num, this is the two integer input variable in num and n. We are reading this input and we are calling this function. Okay, this function will return our output like a nth digit in the num. So we can write this function definition. So int, okay, so both are the integer variable, int like num comma int n. Okay, this is the body, and in this function now we have reading two input num and n. So what we can do, because our n value should be greater than 0. Okay, if our n is equal to 0 or less than 0, we can directly return the 1. So we can write this condition directly here. So if n is equal to, or we can write less than equal to 0. Okay, if this condition is true, then we can directly return answer, return -1. Okay, because this is not an invalid input. Otherwise, what we can do, we can run a loop. So we can set our I value equal to 1. Okay, and sorry, this I we have to define int, and we will set our while loop. So while if this I value is less than n. Okay, so we will repeat this process if our I value is less than equal to n. Okay, yeah. So and each part we will repeat the same process. So we have to return the digit. So we can declare one variable like int output result. Okay, we can like write res. So what we will do first, we will check the digit term. Okay, so we can write like this. So res equal to reminder value. So reminder value is num and percentile this. Okay, that is I, not I. Sorry, 10. Okay, so we are getting reminder from this, and we will also check if our iteration number is equal to the current n number. Okay, so what is the digit actually we are finding out. So and we can directly stop the process and we can return the answer. So I think this is not required. We will add this statement internally. Okay. Okay, here we will check this. So if I is equal to n. Okay. Okay. What we can do, we directly return the answer. So return equal to, so our num reminder value. Okay, so reminder value by 10. This, if this condition is true, we will directly return the answer. Otherwise, we will update our value. So we will update our value like this. So num equal to num divide by 10. So by this line is this statement. By this statement, actually we are removing one digit from the last in each iteration. Okay, if our I is not equal to n, then we are reducing the one integer from the last. If our I will become equal to n, then we will return the answer. Okay, so what are the last digit at that point? So we will return that answer. Okay, so now this loop will return the correct answer if our n is a valid and coming in the range of the number of digit. Suppose if our n value is greater than the length of the input number. Okay, so in that case we can return the answer here -1. Return -1. Okay, so this statement will only run if ever this statement is not executed during the while loop. Okay, if this condition is not satisfied, I equal to 1 by the loop, then in finally this statement will run. Otherwise, at if our n is a valid number, okay, so this statement will run at any point, and that will be the terminate point of this function. Okay, return n this. So now we can see that I equal to 1 and 1 is less than 2. Suppose we are taking second digit, so this is 2. So now our first iteration will complete, and then when I, okay, so we have to increment I also. Okay, yeah, we missed this. So we have to increment our I in each iteration. Now this is complete. So after first iteration, I will become 2. Then this is now equal to, and we will check this condition, and our output will return at this point. So in this manner, we will get the output. Let's check. Some error is there. This is the Python statement. Yeah. So you can see we are getting all test case pass. So in the first example, second digit is 4. So our second digit is 4. In the next example, you can see fourth digit from the right. So this is 8. It is coming in the output. So zeroth, you can see 0 is the invalid input. So our output is returning -1. And in the last example, third digit, this is 3. So all cases are satisfied by this code. Okay. So Any query in this? Any doubt?
No, sir.
Okay. Yeah. So all these are the all 5 PPAs of the Week 5. Okay. So let's move to the practice theory assignment. Okay. So yeah, quickly discuss this also. So in this question, we can read in the following C program, what is the scope of the variable it declared inside the if block? So scope, this scope things we have discussed in Tuesday session also. So scope means, okay, so what is asking, what is the scope of the variable A declared inside the if block? So this A variable, we are asking that this internal A, okay, so this inside A. So this int A is declared inside this if statement. So can we access this A outside from this if statement or not? What is the scope for this A variable? So scope is actually represent where from we can access this variable A. Where, okay. So if it is declared inside this if block, so it can be only accessed inside this block. It cannot be accessed outside of this block. So that means this internal A variable which is declared inside this can be only accessed inside of this if statement, not outside. So this is local for this if block. Okay. So the first statement global to the program, no, we cannot access globally this variable. Local to the main function we cannot also access. So we cannot access this variable from the outside of this if block. Okay, this is also not correct. Local to the if block, yeah, this is correct because this function is a local variable for this if block only. We can access only inside this if block. So this is option third is the correct answer for this. Okay, next is given the following code, what will be the output of the code? So here we are looking for the output. So int x equal to 5. Okay, so we are starting x equal to 5. Okay, fine. Int, okay. And we are finally printing here. So this is also based on the scope things. Okay, so here the first variable is declared int x equal to 5, and second variable with the same name, you can see this is declared inside this brackets. Okay, so the both outside variable x and inside variable x both are different variable now, and internal that inside variable x can be only accessed only inside this brackets, and outside variable can be accessed outside also and inside also. Okay, so that means the above variable this x equal to 5 can be accessed outside. So when we are writing this print statement with x, so this will access only the outside variable which is declared outside of this brackets. Okay, so this means 5 will be printed into the output, not 10. Okay, because this internal variable is different and the scope of this variable is local for this brackets. Okay, so output of this is 10. Yeah, this we have already discussed just now.
Output will be 10.
No, sorry, 5. The above variable will access actually.
Yes, sir.
Okay. Okay, in recursive function, what is the base case? So we have already seen this base case when actually function should not repeat again. Okay, not recursively called again. So you can check the statement, the case where the function call itself. So this is not a base case. Okay, because we are not calling repeatedly in the base case. The initial case where we are calling recursive function. Okay, so this is the main call. This is also not correct. The case where the function exists without further recursion. So yeah, this statement is true because here we are stopping the function recursively without calling recursive again. Okay, So this statement, third statement, is correct regarding the base case. What is the main advantage of using recursion in C? Yeah, so this is simply recursion is more memory efficient. No, so this statement is not correct, because if we are using recursion, so that means internally actually some memory is more used, because we are jumping from one state to the new call. Okay, and after completion of that call, we are returning the answer at the same point where we have called started. Okay, so that information actually we are maintaining in some place, in some additional memory stack generally we call. So that is additional work required by the compiler, so that actually not memory efficient. So this first statement is not true. Recursion simplify the code and make it easier to understand. Yeah, this is statement is correct, because some complex problem we can easily solve by the recursion by writing the recursive function, and this is easy to understand. And next is recursion is always faster than iterative solution. So this is also not true, because additional work is also required. So this is slower than the simple iteration process, not faster than. And recursion allow for better control of program flow. So that is also not true, because same things, additional things are happening inside, recording the current position, that moving to the new uh, statement. So these things is actually not better control flow. So we can say that only option 2 is simply giving the advantage of this recursion function in this statement for question 4. Okay, simplify the code and make it easier to understand. And next statement is, suppose you want to write a function which takes two integer number as input and return the sum of those two numbers. Which of the following function definition is correct? Okay, so this is regarding the function definition. We are taking two integer number and returning a sum of these two numbers. So just check these things in the option. So first function add. Okay, int add, int a, int b. Okay, so this things is now correct till now. And we are writing a int c new variable, c equal to a plus b and return c. Yeah, this is declaration is correct. Okay, this definition is correct for the function. We have declared return type. We have also mentioned the input data type and a and b, and we are performing the correct steps. So option 1 is correct. Okay, so option 2, int add, int a b, int c, c equal to a plus b. Yeah, so this is not correct, because we have declared the return type int, but we are not returning anything from this function. Okay, so this definition is not correct. And next statement is int add, int a, int b. Okay, this is fine. Int c equal to 0, return c. Oh, this is also not correct. So we are performing this return statement at the second statement. So that means our function will return 0 answer from here. Okay, so that last statement will not perform, because we have already written the answer from this position. Okay, so option 3 is also not correct definition. And option 4, yeah, this is correct, because we are reading the two input and return a plus b. Yeah, so this a plus will be equation will be solved and return the correct answer. So option a and d is the correct answer for this. One second. One second. Yeah. Okay, so A and D is the correct answer for this. Next question. Okay, consider below code and what will be the output of the above code. Okay, so here code is given. Okay. Yeah. So in this question, what we are doing inside the main function, we have defined the another function. So this is not a correct. Okay, this is not the correct format to write a separate function, because we cannot define the function inside the another function. Okay, so here this sum function is defined inside the main function, so this is not correct. So it will give the compilation error. Flipkart. Okay. The next statement is, which of the following is a correct way to make the function declaration? Huh. Correct way to make a function declaration alone without function definition. Okay. Without function definition. Let's see. Okay. Okay. So So here what we are doing, we are declaring the function, we are not defining the function. So declaring means simply we are giving the prototype of the function to the compiler. That means we will define this name function in the code later. So what are the declaration type? How we can declare the function in the code? So we have two types of statements. So this is actually a definition, okay, where we are writing the function names, everything, and we are also writing the body. So this is called as a definition, not declaration. So declaration, we can see that this int sum, int a, int b. Yeah, this is correct declaration because we have defined the name, return type, and the very input types. Okay, this is also correct for the declaration. And next is also correct. Okay, so we can also declare the function in this manner, second manner. So without writing the variable name, we can just type the type of the variables. Okay, so int. So this is just a declaration of the function. Later part in the code, we can write the definition like this in the first as a first option. Okay, so in both way we can write the declaration for the function with the variable name or without the variable name. Both are the correct, and this last one is the not correct. Okay, so function name is not mentioned here. Oh yeah, this is not the correct format. So option B and C is correct for this question 7. Which of the following is a correct way to make a function declaration alone without repeated? Oh,
The same question.
yes, 7 and 8 are repeated. Okay, we'll check this. Okay. Yeah, fill the blank. The execution of a C program start from function. Okay. The execution of the C program. Okay. So when we run the code, which function actually called first by default? So that is actually a main function. Always main function will be called first, and the what code is written inside the main function that will run first. And if you're calling the another function from the main function, that the another function will be called. By default, the main function code is executed first. Okay. Now question number 10. So two codes are given here. Two functions are given, add 5 and inc. And inside this main function, we are calling the int a equal to 5, then print statement add 5a and print statement inc a. So what is the order of the function? Okay, the correct order in which the function are written. Okay, so written or exited uh, in the above codage. Okay, so what happening actually? First, we are entering inside the main function. So main function we are entering. So this is the first call. First, we are calling the main function, and inside this main function, this is the second function we are calling. Okay, so add 5a. So this is the add 5a statement. So that means we will perform this add 5a first. And what is the definition of add 5 is actually this. Add 5, this is the return statement. Okay, so that means first we are returning the add 5 statement. So this is the first return statement that will perform from our code. So first call is the main call. Okay, then we are calling add 5 this statement, and it will return the our result first, return x plus 5. Okay, so this is the first. That means add function is returning the first return statement, add 5. After that, once this is completed, then we will move to this inca. Okay, and this is the next call, and then this will return our output. So that means next should be inc. This is the next function with it will return the out back. Okay. Okay, before this we are also calling this print. This is also a function, so that is also considering print. Okay, so we will also consider, because it is also considering this standard function for the answer. So let me delete all the things. So that means we are starting first the main call, then we are entering inside the print f. Oh, this is also one function. Okay, this is also a second call. Inside this call we are calling the add function. So this is the first statement. It will return first value. Okay, so this will return the value, and then print statement, this printf function will return the values. Okay, so add 5, then printf. This is the first return value, then same inc, then printf. This is the second return sequence, and then main part will complete. So that means we can write like this answer: add 5 and printf, then inc call, then printf. This is the print for this, then main call. So option B is the correct sequence for this, for the return. Okay, so how which function is actually returned first? So we are getting the sequence for this. So our add function is returning the first value, then print function, then inc function, then print function, then main function. Okay, this last return statement. So option B is the correct for this, for 11th question. Okay, consider the code, and the output of the following code is. Okay, so here add, we are passing x, y, z value, and we are writing z equal to x plus y. Okay, and x value equal to 1, 2, and z, and we are calling this function. Okay, z will become x plus y. Okay, and print z. Okay, so what happening actually, we are passing, so variable names are same in the function, but the function variable are actually different from the main function variable. Okay, so the variable which is defined inside the main function x, y, z are totally different of the variable which is defined inside the add function. Okay, x, y, z, only value is passing to the function. Okay, so one value we are passing to this above one, two we are passing, and no value we are passing for z. Okay, and we are simply passing this z variable. So, and we are updating this z equal to x plus y. So this updation is happening only the variable of this add function, and we are not returning anything. And finally we are printing z. Okay, so this z is actually pointing to the z which is declared inside the main function, and we have not initialized any value with this z when we are writing the code. Okay, so this is just a declaration. Int z we have declared the value. So that means by default some random or garbage value may be assigned to that place, because we have not declared initialize any value to this variable. So by default some previous garbage value will be there, so that value will be printed here. So option C, you can see some garbage value, or we can see the random value that an uninitialized variable has initially. Okay, because z is not initialized anywhere in this main function, so that some garbage value will be printed by this function. So option C is correct for this. Okay, the output of this code. So this is the main function, you can see. So what will be the output? We are asking the output. Okay, so print statement is there. So first we are calling the from the main function we are calling the f, this one. Okay, fun3, and inside the fun3 we are jumping at this position. So first print statement is there. So that means from, this is the first statement will print from fun3. Okay, after this second statement is a call of fun1. Okay, so we are moving from this point, we are moving to the function call 1. So this statement will be print. So from func1. Okay, now this part is completed. Now we will move to the next call, this one, okay, func2. And in this call we are moving to this function call, and the print statement is from func2, and second statement is fun1. So once again we will call to this fun1, and that statement is from fun1. Okay, so 3 1 2 1, this should be the order of the output. 3 1 2 1. So 3 1 2 1, this option B is the correct for this. So 13th question. So output of the following program. So same things, now we are calling this f2 function here. So f2 we are calling first, f and 2 we are passing. Okay, so this is the function, and n value we are passing 2. So first value is we are printing n value, so 2 will be print. Okay, 2 value will be print, and after that we are checking if n is not equal to 0. Yes, okay, n equal to 2. So this is correct, then we are entering inside this. If n equal to 1, no, this is not correct. Okay, so we are going to else part, and inside this else part we are calling the same function recursively again. So first is fn minus 1, so that means we are passing f1 from this position. Okay, so f1, so this is the new call, so we will directly move to the new call, and now once again we will pass 1 from this point. Okay, so just remember that we are calling from this point, so we will return our value here. So then we are passing 1. Okay, so 1 means n equal to 1, and the statement is now n. So 1 will be printed to the second line, second character. Okay, in the output 2 1, and we will check n is not equal to 1. Yes, okay, 1 is not equal to 1. Now this call, okay, if n is equal to 1, yes, so this statement is true for the this f1 call. Yes, now we are passing fn minus 1, so that means new call is starting from here, so that is actually 1 minus 1 0. Okay, now this is new call. Once again we will start execution from this position, so n equal to 0. So 0 will be print. Now n does not equal to 0, this is false, so else part of this is no else part. Okay, so for this condition no else part, that means this function will be completed without doing anything. Okay, only 0 print. Now the function 1 is completed, so f1, this call is completed. Now we will move to the second call. So this is f n minus 2. So at that time n was 2, so 2 minus 2, this will become f0. Okay, and this is a new call, we are calling from the new n equal to 0, so that means we will get the new 0. And again same.
How n is 2?
No, initially the main call was f2, no?
Yes.
Okay, so
2 minus 2 f0.
so we started from f0, then f0 means only print statement will perform if condition is not true, so nothing is happening. So now you can see all both function is completed. So that means when we are calling this function, so our output should be 2100. Okay, so option A is correct for this. Okay, so this is also similar. Okay, in this code the print statement appears at the end. Okay, so this print actually the same code is given, but only we have changed the print statement at the last position, and we are calling the same things f2. So what will be the output? So f2, we will start f2. Okay, so 2 we are passing here, so that means first we are checking the condition, okay, without print statement. So yeah, this condition is true, this if is not true, then else part, and we are moving to next this position. Okay, so this is now f1, and we are calling the same function again with n1, so that again this condition is true and this is true. Okay, and we are calling f0 from here. So next call, so this statement actually if condition is not true, and then we will move to the print statement, last statement. Okay, so 0 will be print first by this call. Okay, now this 0 is printed.
Please repeat again.
So let me delete again. So yeah, main call is actually F2. Okay, so same call we are repeating. Now print statement is actually last statement of this code, recursive code. So when we are passing two value here, so two value, first we are checking this condition. Okay, this condition is true, 2 is not equal to 0. Then if true, we are entering inside this. So when we are entering inside this condition is not true. Okay, then we will move to the else part, then first statement. So we are calling recursively the main same function with f2 minus 1, so 1. Okay, now this is the new call. New call is starting from again, and now n equal to 1. Once again this condition is true, and n equal to 1, this is also true, and we will enter inside this loop, and this is f n minus 1, so 1 minus 1 0. Okay, now this is the new call, and at this time when we are passing 0, so this statement is not true, and we will directly jump to the print statement, last statement. Okay, this is print statement is outside of this if, so this will be performed. So that means this 0 will be print first. Okay, now this function call is completed with print 0. Now we will move to the back, and you can see I have reached at this position, so this part is completed. Okay, this part is now completed. Now we will move to the second. Okay, yeah, second part. So f n minus 2. So what was the value of at that initially? 2. 2 minus 2 is f0.
Yeah.
Okay, so now we will pass the 0 again. So then we will directly move to this print statement. So 0 will be print again. Okay, and okay, minus 1. Oh yeah, we have missed one statement. Okay. Yeah, so when we are actually calling this f0, so we are getting first 0. At that time our n was 1. Okay, so because of that we enter inside this, so 1. So that means if this statement is completed, if statement is completed, so we will move to this print statement for n equal to 1. So this 1 should also be print in between. Okay, now f1 is completed, this part is completed. Now we are moving to the next call. So this is f0, and when we are passing f0, so we will directly move to the print statement, so 0 will be printed. And now both statement is completed, then we will move to the final print statement with n equal to 2. So this was the initial statement. Okay, so the 2 will be printed. So 0 1 0 2, in this manner output will be come in the output. So 0 1 0 2 is the third option. Okay, last output of the following function. So this is also recursive call. Main function we are passing a function 4, n equal to a equal to 4. Okay, so 4 when we are passing inside this, okay, so if a does not equal to 0, yeah, this condition is true because here is 4 is not equal to 0. Print statement, inside this print statement actually what happening, we are recursively calling the function. Okay, so this is new call without printing anything. This is a new call with function 3. Okay, so this is new call with function 3, one value less. Now inside this function, once again we are when we are repeating a equal to 3, and again this if condition is true, so the print statement will be performed, and at that time our new call will be moved to the function 2. Okay, and the next call will be function 1, and next will be function 0, fun 0. Okay, so this is the last call when we are passing okay, so yeah, 1. Okay, and then it will become 0. Okay, this is not happening. fun 1 n equal to 1. Okay, yeah, this will happen. Actually fun 0. Now when we are calling this fun 0, so our a becomes 0. Okay, so 0 case, you can see this condition is not true, So return statement will perform at this time. So a value is at this place is 0. So 0 will be print first, okay, from last function. Now this last function is completed. This function is returning 0, 0. Okay, yeah, this is the last. So that will print first. Okay, so 0 is coming at this position. 0 will print first. After that, this is now completed. So yeah, next call. Okay, so what was the last return statement we are getting? So for this function 1, okay, this function we will return 1. Return 1. So this 1 will be printed and next value as a, okay, and for this call return state, this statement will return 2. Okay, so 2 will become at this point, and then 3. Yeah, so this, in this manner your output will come. Okay, so 0, 1, 2, 3. So in this recursive way, 0, 1, 2, 3, option C will be print by this code. 16. Okay, so one additional question is added. Okay. 16, this one. Choose the correct definition of the scan print if it should read 5 input and print them in the same order. Okay, scan print high. Okay, definition, it is asking that if we are here we are reading the 5 inputs and we want to print into the same order in which we are reading the input. Okay, so that means this is also a recursive function. You can see. So this is the main call, scan 5. We are passing scan 5 here. Okay, and we are calling this function, and definition you can see, to print into the same order. Our print statement should come at the first place before the recursive call. Our print statement come, then our recursive call should be happen. Okay, so then you can get the same order as the input order. Otherwise you will not get the same order. So you can see in the first option.
Sir, I can't understand this.
So what happened actually, if you have written some recursive function, and what here we are asking, if we are reading the input, okay, and then this first statement is reading the input here. Okay, so this is the reading the input. Suppose here we are passing like one value. Okay, now this is the recursive call. So this recursive call is there. It will move to the new function. So again it will read a new value for the a. So like second. Okay, and this print statement is coming as a last before after the recursive call. So that means this print statement will perform first for the last call, last recursive call. Okay, so that means if this print statement is coming after the recursive call, your output will be print in the reverse of the order from the last position. So like 1, 2, 3, then 4, 5. So when you reach at the final position, so that 5 will be print first, then 4, then 4, like this. Okay, in this manner your output will be print in the reverse order. So this option is not correct. And when you move to the second option, so same things here also we are doing the same. Okay, last print statement after recursive call, this is also not correct. So this is we have to check, because what we are doing, we are reading the input. Okay, so we are reading like 1, and same time we are printing. So that means our output will print first, then we are calling to the new recursive call. Okay, so in that case we will move to the second call, and then we will read new input and we will print. So suppose in the next call we are reading 2, and then same time we will print 2. Okay, in the next recursive call we will read 3, then same time we will print 3, in this manner. So we will get the same print order in which we are getting the input. So when we are writing this print statement before recursive call. So this will happen before the every recursive call. So you will get the same output as input. And next call, So here we have to check the condition. So what is the difference between option 3 and option 4? So this is the condition, okay? Condition based difference. So we are starting from I equal to 5. So in the main call, actually, we are passing scan print 5. Scan print 5. So our value, okay. Yeah, so you can see we are starting this I value as a 5. Okay, so in the first call we are getting 5 is greater than 0, yes. Okay, then we are decreasing this I, so then 4 is greater than 0. So in this manner we will read 5 input value. Okay, but in the lower, the condition is given I less than equal to 5, I less than equal to 0, and in the first call we are passing 5. Okay, so 5 is less than equal to 0, no, so that means the statement will not perform in the first call itself. So this if condition is not true, correct, in the last statement. So this will not perform any recursive call or any print statement. So only option 3 is actually performing 5 recursive call with the print statement in the correct way. Okay, so option 3 is correct for this last question. Okay, so we will remove this one question because I think this is mistakenly added. Otherwise, total 15 questions there. Okay, so these are the practice theory and practice programming. So just you can try. And if you have any query, then you can ask.
Sir, I have a journal query.
Hmm.
Quiz one for mock is graded or not?
Quiz 1 mock. You're
Yeah.
asking mock?
Yeah, sir, mock.
Mock is not graded.
Okay, thank you, sir.
But I think sometimes some bonus marks is actually associated with the this mock activities. So do not skip. Just submit some answer. Okay. So because of that, it is released as a graded. So some bonus
Okay.
criteria is there. So just check your grading document if any common bonus things are there or not in the ES program. Because in DS program, I think I remember that some bonus is there based on the mock questions. Mock. Okay. So just check the grading document.
Okay. Okay.
Okay. Okay. Anything else? Any query? Okay. So today just attempt the timed assignment from 8 p.m. Yeah.
Thank you, sir.
Okay. Thanks everyone.